Hello there, my name's Vince from My Mate Vince, and welcome to a tea break fix. Haven't said that in a while. My choice of poison today is an alcohol-free, I'm being good, Kopparberg mixed fruit. Really sweet, which is good for me because my sense of taste ain't that good, so I like sweet things. Right, we are going to be looking at this Bush radio here. It's brand new, but it's not working. It says here, stopped working, holding power with batteries. So I've plugged the adapter in and there's nothing happening, yet we do have voltage here. Weirdly, I plugged in what I thought was 4 good batteries. And when I went across the probes at the back, the contacts at the back, it was coming up as 1.4 volts. And when I went across each battery, it was only measuring 0.4 of a volt. And now bit by bit, they're climbing back up. I'm wondering, I mean, don't get me wrong, they could be flat, but I'm wondering whether this is putting some weird short on it. So I won't bother plugging the batteries in now because it's not working with this anyway, so it is definitely faulty. This is 5.9 volts and it says at the back here, center pin positive. 5.9 volts is a kind of odd voltage to have. You think it would just be 5 volts, but there you go, 5.9 volts, 1 amp. This is definitely the correct charge power cord for it because it says 5.9 volts on it. And when I plug it in and put it into the back here, nothing's happening. So you can see there, nothing's happening up on screen. And if I go here, you'll see we'll have 5.9 volts. There you go. So we need to take it apart and see what's going on. It's currently sold in Argos as a current product for the grand price of 20. Look at that. $24.99, yet you get 30% off if you use the code RED30. So there we go. It's a simple little one that somebody might put in their kitchen to have a little bit of background noise. I don't think it's going to be anything too major. I'm hoping it might be a little bit of a quick, fun video, hence the reason I'm calling it a tea break fix. Right, let's get a screwdriver, undo these ones here. 6 screws at the back. Looks like it's going to be nice and easy to take apart. Right now, what have we got here? So, power board at the bottom here. Batteries go over to here and this goes over to here. So I presume it gets cut when the batteries, when you plug something in here, it cuts it to the batteries to stop the batteries from being charged. I presume that's what's happening. Right, and it goes into here. So first things first, let's plug in the power cord into here and let's see if we have the right voltage here. I'm just wondering why have we got 3 wires? Maybe sometimes it takes it from the battery. So maybe 2 of these are from the power and 2 of these are for the battery. That might be it. So black in the middle and we'll go to the white one. We don't have anything. Black in the middle and we'll go to the red one. And we've got voltage. So would the white one be batteries? Let's plug in the batteries now. See if any of them's grown yet. So I'm not sure if you short a battery how long it takes. These batteries must just be flat. That's really weird because they were in my new pile. That doesn't make any sense. And I only had them plugged in for about 30 seconds. That's so strange. So they look to be just under 1 volt each, so we should have about 4 volts here. Let's see if it's on the white wire. No, but we've got the power cord plugged in, so let's unplug that, and now does that pass it through? Yeah, okay, so that's a battery there. Okay. So when you plug it in, it does kill power, which is correct. 3.7 volts. Plug it in, and it should kill power now to the batteries, which it has done. Right, well that's operating correctly. So we need to be following the black and red, so it's worth doing that because now we know we're going to be following the black and red here. So it might well work with batteries, but either way we want it working with power. So let's take out this little board here and see if it's going to come apart more. I've already noticed here, look at that, that's not doing anything. Can you see that? I don't even know where that should go to. I can't see anywhere where it would have gone originally, unless it was soldered onto... Oh, do you know what? I bet it was soldered onto that there. That little jumper. That wouldn't stop it from turning on though, would it? No. That's just for the aerial. There we go, pulls out. Right now, why are you not working? There's not much on here. There's not much on here. That's right, negative there, negative there, negative, because the board's marked up nicely. And negative there, so they're all correct. So we have got, it says here, battery, ground, positive. So let's just make sure that that is the same way. So when we plug it in there, we know that the... Oh, it was this way around. Yeah, we know it was on the black and red, which is correct, plus 6 volts and ground. So that's correct. So we should be able to follow it from here then. So we're looking at this one here. So it goes through a diode. Down here, across here, another diode. Okay, and then the battery goes up this way. Let's have a quick visual search around the place because everything there looks all right. Separate little board up here. We have a hole in that chip, do we not? 8002. I've heard of that. I think that's the audio chip. Let's see where the speakers get connected to. So speakers are over here. These two. Yeah, that's the audio chip. 8002. There's a hole in it. So that's why it's not working. I wonder if there's a weird short or anything there. Let's get the flare cam on, just to see if there's any heat spots anywhere. Oh yes, we have a heat spot. Look at that. Right on the chip. That is on the chip. So if you have a look here, I'm going to prod the middle off it. Yeah. Okay, there you go. Well, maybe that's somehow draining the power and stopping the power from going to the screen. Let's pop it off. Now, before I search for one of those chips, that was perfect. Let's have a word from today's sponsor, PCBWay. PCBWay is your one-stop solution for all things PCB fabrication and assembly. From rapid prototyping to full-scale production, PCBWay delivers top quality products. So whether you're a seasoned engineer or a hobbyist just starting out, PCBWay's user-friendly interface makes ordering your own custom PCBs very easy. And PCBWay do a variety of different services, including but not limited to assembling your PCBs, CNC machining, 3D printing, sheet metal fabrication, and injection molding. So when you're ready to take your designs to the next level, look no further than PCBWay and bring your ideas to life. So as always, a massive thank you to PCBWay for sponsoring the My Mate Vince channel. Now let's get back to the video. Shock, horror of horrors, I've got them! Unbelievable. I think they were from some DAB radios I did ages ago. I can't remember whether they're the John Lewis ones or the Blaupunkt, or whatever it's called, ones, but it looks like I bought 10 of them and I've definitely used 3. So they are a popular chip, and as soon as I've seen those numbers, I do remember that chip. Now this is down here as 8002B, while this one is just down as 8002. And I was wondering, is there a difference? I don't think there will be, but it says here, it's not, this is just AI, it's not the same, but the B might be an enhanced version of it, but they are often interchangeable. So I'm sure it's going to be fine. Right, so it's going to go on that way around there. There might be a little bit of burning going on here. I'm going to use some hot air. I'll try to angle the heat this way, but the corner of the screen might get it ever so slightly. Or, do you know what? Why don't we just use some low melt solder and then there's no risk at all. Let's just take it off with the soldering iron, put it on with the soldering iron. That way then we're not going to risk burning, just in case. If I've been blessed with an easy fix, I don't want to make it into a hard fix by trying to source a new LCD for it. I'm going to flood this area here. It looks like loads, but it's hardly any. Let's get some on top. A bit of a spit. It's spitting a bit at me. Here we go, look at that, it's wanting to come off already. How amazing is low melt? Miracle stuff. Don't ruin it now, Vince. Lovely. Amazing. Right, let's wick that up. So low melt's really expensive, but you use so little of it. Right, that's all clean. Let me get some IPA on that, make it nice and pretty. Then we can get the new chip on there. Isopropyl, 99.9. Here we go. How nice does that look? No damage whatsoever. Right, nice bit of flux. And pin 1 is top right, because I remember. Right, I've got leaded solder here. Annoying that moved. Let me try to get it back into position. Lovely. Right, there we go. So you can see that that's in position now. Pin 1 up here and is all nicely soldered. Nicely is debatable, but it's soldered. Right, let's put the power back in, see if the screen comes alive. Turn this on here. Now, you ready? What? You're still not working? Right, let's unplug power. Let's get the FLIR cam and see if that's still burning up. It's never straightforward. And this is where a nice 15 to 20 minute tea break fix turns into a whopping great trying to fix video. Apologies, what can I do? No, it's not burning up now. Look at my thumb. You can see that there's nothing burning up, yet it's still not working. I wonder, did somebody plug a more powerful adapter into it? Right, well, there's nothing lighting up there. So I presume the brain of this is going to be underneath that screen. So let's try to pop the screen out. Maybe the actual main chip's gone. Right, how do you come out? So you clip here, clip here, clip here. Right, so that goes in here, but that's soldered to the board here. Okay. So that should still, no, that's not going to work, but we might have a backlight. I wonder, has that chip... See, the thing is, there's not much really going on here. Right, we'll put power in again and we'll see if anything's getting warm here. No, nothing's getting warm there at all. So that's okay. Well, I suppose what we could do is let's get some fresh batteries, pop it in, because if it is indeed working with batteries, then we'll be able to do the circuit better, because it will probably mean that this chip is okay. Right, I got some super expensive lithium. Still AA batteries, not rechargeable. They're supposed to be powerful. Let's see what voltage we have on these. We need 4, don't we? I think the voltage is slightly higher on these. .8. Wow, have you ever seen that on an AA battery? 1.8. Hope it doesn't blow it now. In, turn on, hold in, still nothing. So it's not working okay with batteries. Right, let me just measure here just to make sure. Well, actually we can go straight onto the contacts here, make sure we've got a good voltage coming into it. So it's going to be up the top here. Yeah, there you go, 7.2 volts. Right, okay. Seven volts there. Goes to nothing. I don't think this is looking very hopeful, unfortunately. There's not much on the board, and it doesn't look like we have any shorted caps, but I'll check just in case they're not showing up with the FLIR cam. I think it's going to be that main chip up there. I don't think this is going to be one that's going to be successful, which is a shame. Okay, I'm going to take that. No, I can leave it in. No biggie. Right, let's zoom in and we'll just go on to continuity for the moment. Well, we'll start around a faulty chip because we know that it was faulty. Right, I'm going to put one probe just to ground, so I'm using this here on the input, the middle one. Right, let's go across things. See, that's short in, but it's a 1 ohm short here, 5 ohm short here, so it could be just completely normal. 1 ohm, 14 ohms. You've got to be careful when you're measuring near chips like this, because a lot of the shorts are meant to be there. They're not actually shorts. So I'm looking for something which might have like a 1 ohm short on both sides. That might indicate a shorted cap. So that's 1 ohm there, 5 ohms here, 1 ohm here, and 20 ohms here. So I think that's all normal. Yeah, I mean, there's lots of beeping going on both sides, but even if you look at this cap here, so if I was to go on to the negative of it, which is this one, you will see it's like, you know, less than 1 ohm. But on this one, it's like 3 ohms. So 3 ohms. It's kind of weird though, that doesn't seem much. It's on that rail there. So everything on that rail is going to be 3 ohms. Might be normal. So we've got an inductor. So I suppose what I could do is I could take the inductor off and see if the 3 ohms is coming from this side. You know, because maybe this is faulty here. Maybe this is burnt out. Got a dot of solder here. Now let's slide that along. I've got my temperature 450 degrees Celsius, airflow 150 out of a possible 200. It shouldn't take long. There we go, it's off already. Do you know, I won't slide it, I'll take it off completely. Now let's see which side it's coming from. So I'm on the capacitor now. Wow, it's coming from that side. That's really good. So let's go this side of the inductor. No, that's 8,000 ohms. So is this side here. Do you think my electrolytic's gone faulty? Right, let's see now where that short is coming from. Is it a cap? I'd like it to be the cap. Please be the cap. Come on. Ooh. I got excited there, that was my leads. No, it's not the cap. Okay, now. What we got? 4 ohms. Let's zoom right in. Maybe there's more on this line that I can't see. I don't want to end up stripping out the whole board. Well, I check all along the line. Initially I thought it was just 2 SMD capacitors, but it's not. It then goes off, it goes up to that little soldered on board with the main brains, the main chip, and it also goes down to a load of capacitors by the screen ribbon cable connector. But the thing is, it's not a complete short. If it was like a 1 ohm short, then I could add voltage to it, or it would even show up on my FLIR cam, probably, if it was a shorted cap. It's a 4 ohm short, which seems weird. So I soldered my capacitor back in, and then I just check for voltage. And check this out. All of the electrolytic caps have voltage on them, apart from the one that we've just taken out. Let's plug this in. So we haven't got anything at that capacitor. Let me try to turn that on. No. Okay, where's the other caps? There's one over here. Right, we've got 5.5 volts there. And 2 down here. .5 volts. We're definitely homing in on it. Because look, all of these have voltage, so what's the point of having this cap here? Should we start tracing the circuit back on voltage DC and see if we can get voltage anywhere? Anything here? No. So there's going to be nothing here. And this does the backlight, so we need voltage here to get the backlight working, because there's no voltage on the backlight at the moment. Okay, do we still have voltage on our power button? Yes we do, 5.5. So here, nothing. Nothing up here. Nothing. Nothing. So is this a voltage regulator? Oh, this might be a voltage regulator. Nothing there. Nothing here. Nothing. Nothing. Bingo. 5.3 volts. 5.3 volts there. Nothing here. Oops. Nothing there. Nothing here. And nothing here. So that's not doing anything. Let's turn it on. I'm going to hold this down. Let me just see here. So that whole rail is not getting anything. 5.3 volts. Oh, we have 5.3 volts here. Did we not have that before? 5.3 volts here. Nothing here. 5.3 volts here. So we have 5.3 volts at the top, but nothing coming out. Right, So this isn't doing what it needs to do. Should we see if we can get a marking on it? S5ENA has to be a 5-volt voltage regulator, doesn't it? No, maybe 3.3 volt. Let me Google that, S5ENA, and see what's happening. So I have a look on Google and I can't find this little component. And yeah, nothing's coming up whatsoever. But I do a little bit of research on voltage regulators and I actually learnt a little bit about them. So I'm going to cut to the next day now and I'll tell you what I found out about voltage regulators.
The next day.
Right, so next day now, and I feel like I've learnt a little bit. Only a little bit, I can't overload my brain. But basically, this is what I think is a voltage regulator, yeah? But it's got 5 pins. So I did a little bit of reading up about voltage regulators. And you have 2 different types. You have linear and you have switching. And I've often seen 3-pin voltage regulators here, or what often happens is you have this one going through here as well, kind of thing. And I never really understood the difference between them, but it's really actually very, very simple. So basically, a linear one is where you would have a ground. Pins can vary. You would have a voltage in and a voltage out. And you might have, for example, 5 volts in and 3.3 volts out. And the reason you would use these is because they're very simple, but the reason you wouldn't use them is because they're not very efficient. So do you remember years ago you had linear power supplies and everything? Really heavy power supplies, but incredibly simple. Just a big coil of wire and another coil of wire, and it induces across and turns maybe 30 volts AC into maybe whatever, 12 volts AC. Yeah. Well, in a way, this it's not the same, but it's doing something very similar, as in it's converting 5 volts to 3.3 volts, but you're losing lots of energy from heat. So that's how it's converting it. I think, don't quote me on this, probably well wrong, but I think if you imagine like a switch and there's resistance on that switch, so it's allowing some through, but not all. And the stuff that's not getting through is basically going off in heat. Yeah. So I'm not saying that's how it works, but it's not very efficient. What I like about it though is it's very simple. Now, a switching one is much more efficient because what it's doing is it's not just voltage in and voltage out. So you might have voltage in here. This might be ground here. And then you're going to have voltage out. But then you might have other ones, like you might have a feedback. Yeah. Or you might have a enable. And I think what happens on these ones is they're quite clever in that they're switching. So it's not a case of we're going to put 5 volts in and burn off all the excess on heat. You're putting 5 volts in, but you're turning it on and off. So basically, if we had 5 volts here and 0 volts here, yeah? If, for example, it was like this, 0 and then on and then off and then on, yeah? Then can you see it's off for only a small amount of time? So this might actually equal maybe, I don't know, like 4 volts. Yeah. But then if you wanted it to equal 5 volts, 0, if you wanted it to equal maybe 1 volt, then it would be basically on, off, like that. Yeah. And so you're not losing anything from heat. You're just turning it on. I think this might be the same as pulse width modulation, but I'm not too sure about that. And you can see why, if it's only on very quickly, then you're going to get a lower voltage than if it was on more. And I think then to smooth out this signal to make it like a nice DC straight signal, I think then it needs to go through an inductor, and we know our circuit is going through an inductor. And I think also then that gets cleaned up with a filter, because I think with the inductor, if it was just like this, I don't think it would work properly, because the radio would be saying 5 volts off, 5 volts off, 5 volts. But I think when it goes through the inductor, because it takes time to charge and then time to collapse, I think that takes away maybe this here, and then it equals it more, it levels it more out, I think. And then it goes through the caps to clean that signal even more. So I actually learned a little bit. Now, when it comes to the switching ones, we know this is switching because it's 5-pin, but then you can also have ones with a fixed output. So for example, 5-volt in, 1.8-volt out. And I think you can have ones with a variable output. And I think it's a variable output via the feedback, and it needs to go through resistors like a voltage divider. And then what I'm not sure about though is, does the engineer who's designing the circuit decide what the output is? So they decide on the chip, then decide on the output by putting different resistors, or does the circuit change the output depending on the demands of it, like a switch mode power supply? So for example, if I had the voltage up, full, nice sound effects, thank you, then it would need to adjust this to put more out. Not too sure. And then does it change the voltage, or does it change the current? Again, I don't know. But anyway, I didn't even know the difference between a 3-pin and a 5-pin. And now I know. So basically, I love these because they're nice and simple, but they're not going to be energy efficient. So I suppose if you were to have one of these in here, you're going to run the batteries out quicker. If we have a look at this board here, lots of that will be incorrect. I'm just sort of saying it how I kind of read up about it in my head, but there will be lots of inaccuracies there. But if you have a look here, so we know now up here that this one is linked to this one. So these are the voltage in, and we know it's 5 volts. This here is the ground. And then I think this is the output, because if you look here, it goes via the inductor. The inductor then gets cleaned up by the capacitor. Looks like it might be getting cleaned up even more here or doing something else. And then it goes off into the chip here. It also goes off down in this direction to feed, I presume, the display as well. I wonder, is this a voltage divider? Because if you look here, we've got it coming out and it goes through a resistor, and then it goes through this resistor to ground, because this is grounded via this 0 ohm thing here, and this is all ground. You can see it goes to that pin here. This massive plane here is ground. So if it's tapped off down here in the middle, this is a voltage divider, isn't it? Because it goes through here, and you tap off the middle. So this rail here now is a voltage divider, which I think goes down to, I'm not sure. Does it go down to here? Down to, I'm not too sure. But anyway, so I think maybe this does have an adjustable output, but I can't find one, unfortunately. But now, because of that, you would be able to take a guess at maybe what you would need. And I would say it's 5 volt to 3.3 volts, but I don't actually know that. But because I have a lot of Bush products, I have got this board here, and amazingly, although the board is a different size and stuff, it's pretty much identical. Yes, the screen and stuff's on this side, so the connector's here, but look, this chip looks to be the same up here. And if we look really closely here, what do we spy? We spy the same voltage regulator. So I haven't got to take any guesses, I can just take it off here. So let's pop this chip off, because it's a 5-volt voltage regulator, looks to be identical to the one from the other board, and it's in the same sort of place as the other one. So let's take that, put it in our board, let's see if our radio finally comes alive. Let's plug it in and see if it's going to work. I think no. I think it's going to come alive, but I don't think it's going to pick anything up. You ready? And we're in. Flashing. Let's unplug that. So it's not happy, is it? Actually, I want to try that one more time, because I just want to turn it on here. On. No. Right, I think we need to find out where this 4 ohm problem is coming from. So I think it's this chip up here. So we know that the rail here with the 4 ohms is coming up here. So that's nice and easy to measure against. I'm going to go across the chip. I want to see where it comes up. Up here. So that looks like, if you ask me, a corner like that, massive trace, that looks like a power in. Mind you, it's all up here. Oh, it's not. It's that one next to it. It's that small one. It's everywhere. Oh, it's here as well. Well, do you know what? There's a chance it could be this chip here and here. Let's take this off because I've got a full short there. That's interesting. So this is, it's a full short to here, but it's 4 ohms to here. Imagine if it was that one. That would be an easy one to change out. Look, let me go into normal resistance. If I go here, you can see a full short. Yeah, under 1 ohm. And if I go there, you can see the same short that I have on the capacitor. So that must be the ground there, and that must be the actual one that's in contact. Let's take that chip off with some low melt solder, and let's get the one from the other board on. If not, we're going to have to take off the whole board here, I think. Right, the markings on this are upside down, so I know which way to put the other one on. The reason I'm using low melt here is it is quite close to that chip and I don't want to wipe any data or anything on it. Hold on. Heat that up there and here. There we go. Oh, come on, Vince, I made a right mess of that. What? Oh, I feel like hands aren't working properly today. It doesn't help my tweezers now have gone. They're not as good. They used to be so sharp before. There we go. Right, let me just see if I've messed anything up there. Still dropping stuff. Nah, it's all good. Actually, do you know what? We should see if that 4 ohm short's gone now. I mean, it doesn't mean it is the chip. It might be just passing through that to this one here. Let's see if it's disappeared. Come on. No, this is not that chip. It's not that chip. Okay. Well, I think we can just assume then. I mean, it's coming up everywhere. I think we can just assume it's that one there. I'm going to replace the whole thing. I think I'm wasting my time. The 4 ohm short is still there, yet on the other board, it isn't. So if I was to go here and here, you can clearly see it's not. I think it's blown that. I think it's blown that main chip. Oh, what a shame. Okay. Well, I'll tell you what we do, because this is scrap. This is now scrap anyway. I do want to know, because some people are going to say maybe it was the capacitors. Why don't we take off this big chip and then see if the 4 ohm short has gone, and then I think we can safely say then that that was the problem. If when I do this the 4 ohm short is there, still there, happy days. I'll try to get the chip back on, and then I'll chase all the little capacitors. Maybe we can go on to millivolts and it might show up the faulty component using millivolts. But I think it's going to be the chip as a whole. This is going to be hard to pick up, this one. I'm not sure if there's a big heatsink in the middle of it or not. I thought it would have lifted. Oh no, the whole thing's lifting. Haha. Oh no, I wanted just this to lift. The whole, oh, there we go, it's lifted. The whole board was lifting there. Massive heatsink, you see. Well, I think the board's still soldered into place. Just. Now imagine if the 4 ohm short was still there. You ready? What do you think? Yes or no? I think no, it's going to be gone. It's gone. There you go. So yeah, whatever surge has happened on this is taken out this chip, and this chip. Probably not that one there. But we could put that one back on just to see, couldn't we? My shakes are terrible today. Oh my word. Oh my word. They're all over the place. Today's not a good day for soldering. I have just had a double coffee. Double espresso. That could be what it is. Right, I'm going to say that the short has still gone. Let's see, do we still have the 3 ohm short or 4 ohm? No, we don't. So that chip itself is okay. So I think we've proved it now that the fault is with the middle chip. But because I'm using the other board anyway, I might as well take the whole thing off. I hope it's going to be programmed okay for this one. I'm not sure what does the... That's just a DAB chip. I'm just not sure whether certain functions are only going to work. Do you know what I mean? I don't know if they're all gonna. I don't know what does these functions here. Is it the chip or is it this little one here? I'm not too sure. So I may have to swap that one over if it doesn't work. I'm hoping this main chip will be okay. But is this how they program it in the factory? Maybe I can't swap it over. What can I do? Let's give it a go. Now, I have to decide, am I going to heat up the whole thing like I did before and try to lift this off? Because what I could do is I could slide it off that way. I think that might be the easiest way to do it because it nearly came off before. So let's zoom in. Let's slide the whole thing off this direction here. Then I can clean up the pads and get the other one on. While I'm doing this, I'll give a shout out to the lovely My Mate Vince Massive. The members this month are Keymon Services, Kip Hakes on YouTube, Max Rokotansky, Chris Seal, Felipe at MrKeebs.com, DJVG, Pigsy, Anthony Dean, Russ Melanson, Shigate, Rickard Bergland, Soul Reaver 555, Shamsa Al Savadi, Stuart Park, Stephen from the Broken Past on YouTube, Lee Benz, Niall Stone, Operational 117 and AJ Computer Services UK. Many thanks, guys. There we go, off you get. Let me just sort that one out. Okay, so now I'm going to clean up these pads here. Apologies, the video's starting to drag, so I'll just fast forward through this bit. I'm cleaning up all the pads, then I need to get the DAB off the other board and put it on here. This isn't economically viable in real life. It's fun for a video, perhaps, but you wouldn't normally be doing this. Yes, if there was a shorted cap or maybe the audio chip, you might do it. It's a £25 radio. If it's especially your own, you might do it, but you're not going to be chasing the faults the amount that I'm chasing through this one here because it's a £25 radio, currently with 30% off. So knock another £7.50 off that, and then you're left with something which is £17.50. I've been on this for hours already. Also, who out there is already going to have a Bush board with the same chips on? I'm lucky. I've previously bought job lots of Argos returns, so the board could well be from maybe a Bush radio where the casing was damaged, but yet the inside board might have been okay. I've got quite a few Bush boards and Bush radios, so I'm blessed that in this instance I've got spares to choose from. In real life, if you didn't have spares, you wouldn't be able to get these parts here, or if you could, again, it wouldn't be economically viable to be buying these DAB chips and these 5-volt switching regulators and these audio chips. Yes, audio chip on its own, well worth fixing the radio, but not when you're chasing one fault after another. So yeah, we've got the other chips soldered in now. Let's turn it on. Surely now, at long last, it has to be working because this is the third thing that we've changed over. Okay, let's now see if it's going to work. Right, fingers crossed. Let's see now. Are you going to work? Are you ready? Come on. That's worrying. Am I plugged in? Yes, I'm plugged in. Let's turn it on. Uh-oh. Oh no, oh no, oh no, oh no. Oh, phew. Whew. God, got me worried there. I'm not plugged in. Right now, are you going to work? Yes, come on. Brilliant. Time is not set. Will it work if I turn it on? No radio. DAB. BBC well connecting. Fantastic. Okay, let me put it back together, tune it up and stuff, get the speaker on, and hopefully it will work. Okay, it's back together. I'll try it on batteries in a minute. Let's see if it will tune in.
Accusing it of fostering anti-Semitism. The university responded with legal action, and a judge has now temporarily frozen the policy. But thousands of foreign students have been left in limbo. One said they were
just spilled my IPA again.
Another said their dream.
Why is volume not working?
Our North America correspondent John Sudworth.
Oh, what? You press it to go down? How bizarre. I was wondering what clicking means. Okay, that's bizarre. So whether you turn it either way, it goes up. That doesn't seem right. What? Hold on a minute. Something's not right here. I think I need to read the instructions. You know what it is? It's because it's programmed, the chip's programmed for a different radio, isn't it? So it must be this to enter and volume up and down like that. So yeah, the other radio that this was attached to must work differently. Oh no. So unless I can swap over the little chip, you know, this little chip, unless somehow that's got firmware or something on it, it's possible. Yeah, it's not even scanning, I don't think. Nothing's making sense. Right, I mean, it's corrected my one here, so maybe I wrote it down ever so slightly wrong. But yeah, look here. It's a serial flash memory. So I think it's going to work when I swap it over, unless, of course, it's been blown up. So I'm going to add low melt solder to this, because it's flash, so I don't want to put a load of heat on it. In case I wipe it, then I really will be stuck. This Bush radio really doesn't want to be fixed. So I'm hoping now if I swap the little flash chips over, so the radio that I've been working on from the beginning will have the original flash chip on, but it's going to have a different big brain, big DAB chip. Hopefully that might fix the problem, because the radio's working now, it's just not working with these button inputs. You've seen me swap enough chips over now, so I'm just putting back on the flash chip. I'm using low melt solder and a soldering iron. I've already heated up this chip anyway with hot air, but I'm going to lessen the chance of wiping it by using the low melt solder. So let's try it now that we've got the original little flash chip back on the new board. Right, okay, so we're on upside down again. Let's put this original sticker back on. There we go. Now, are you going to work, or have I ruined it by applying heat to it before? Let's see. This radio's needed more stuff than I than I thought it would. Come on, please now. Let me finish up the video with a success. Time is not set. Okay, fine. Turn on. Can I do the volume? Yes? Yes! Volume works. Brilliant. Okay, right, I'm going to put it back together and then we'll try to tune it up and see if it comes alive. It says time is not set again, but when I do the scan, that will work. Oh, brilliant. That's so nice to see that little volume thing working. Yeah, let me take it elsewhere. I just want to see... Oh, here we go.
We have to totally
Fantastic.
stop child benefits. I'm of the age, the 40s and 50s, prior to any
Fantastic. Okay, I just want to see... Let's turn that off. I want to see if it's going to work on batteries. It's got the time now, which is nice. I think from memory, things like this don't work on time. The time doesn't work when you have batteries in, which I suppose is good. You're not using it as a clock radio then. You can use this as like a clock radio. It's got the option to have a couple of alarms on it. So now let's see, no clock. Turn it on. Yeah, here we go.
and this was in the 40s, right? And we
Fantastic.
depended on child benefit because
Turn it
my
off
father could...
and the screen will go off. Right, let's find a spot for it and finish up the video. We are done. So we can take that faulty sticker, roll it up and throw it away. It was quite challenging. Correct me if I'm wrong. I think what happened here is I don't think the person who got this from Argos used the correct power supply. I think they plugged in their own power supply. For whatever reason you would do that, I'm not too sure. But I think they plugged in a 12-volt power supply and that took out the voltage regulator. You can see how small it is in real life. And took out the audio amplifier and also took out the main brains as well. But luckily it's working now.
Criticism from other world leaders is...
So yeah, I've gone through the different thing. You've got FM, you've got DAB, and it is picking up a few stations. My reception in this house isn't great for FM or DAB, but yeah, I thought that was kind of fun there. If you enjoyed the video, give it a big thumbs up. Hopefully I'll be back again soon with another video. Sorry that this wasn't a tea break fix, but as you can see, it was actually quite involved. But yeah, it's nice. I quite like it, even though it's not the best quality. Take care, everyone. I'll see you soon.